Okay, so now we're going to actually prove the same side exterior angle theorem. We've proved the same side interior angle theorem, the alternate interior angle theorem, so let's prove the same side exterior angle theorem. Remember, the same side exterior angle theorem says if the lines are parallel, then the same side interior exterior angles are supplementary. So I want to prove that. I've got to prove that, okay? So I want to prove that 3 and 5 are supplementary. So remember, as in any proof, your first reason is always your given. So what am I given? That line R is parallel to line S. Always goes first. I always like to mark my lines just so I know they're parallel, okay? So let's move on to the next step. We don't know the alternate exterior, the same side exterior angles. That's what we're trying to prove. If we weren't trying to prove that, we could actually use this theorem, but we're trying to prove that theorem. So let's use what else I have. I have corresponding angles here, okay? So I know that angle 3 is going to be congruent to angle 4, and again, that's the corresponding angle postulate. The corresponding angle postulate says if the lines are parallel, then the corresponding angles are congruent. So I'm going to use that principle here. All right, now let's look at the next step. I've tied 3 and 4 together. I'm trying to tie 3 and 5. So if I can tie 3 and 4 together and I can tie 4 and 5 together, then I can make a connection. Well, let's look at 4 and 5 here. 4 and 5 form a linear pair. 4 and 5 form a linear pair. Now, it depends on, again, the requirements that you see that your teacher or your professor has. Some people will actually make you write 4 and 5 are a linear pair. I'm not going to make you write that. But we do know that a linear pair, okay, that a linear pair, I know the measure of angle 4 plus the measure of angle 5 is going to equal 180. Now, we've been saying definition of linear pair. That's also the linear pair postulate. The linear pair postulate says that two angles that are a linear pair are going to add to 180. There's all kinds of ways you can write this. It just depends on preference. Some people will make you say that they're a linear pair first, then make you say they're supplementary, then represent the equation. I'm not going to make you do all those extra steps. So we're going to do measure of 4 plus measure of 5 equals 180, and that's the linear pair postulate. Now, moving on to the next step. What we have next for step 4, what do I know about 3 and 4? 3 and 4 are congruent. So I can use substitution to stick angle 3 in for angle 4. So instead of measure of angle 4, I'm going to make that measure of angle 3 plus the measure of angle 5 equals 180. All I did was substitute 3 in for 4 because I know 3 and 4 are the same. So that's just simple substitution. Now I'm trying to prove that 3 and 5 are supplementary. Since I know 3 and 5 add to 180, I can now say angle 3 and angle 5 are supplementary. And that is by the definition of supplementary. And you're done. Remember, the given always goes first and what you're proving goes last. Some people will make you actually write angle 4 and angle 5 are a linear pair by definition of linear pair. Then they'll make you write angle 4 and angle 5 are supplementary by linear pair postulate. Then they'll do measure of angle 4 plus measure of angle 5 equals 180 by definition of supplementary. I'm not going to make you do all those steps. Our goal here for our class is to teach you the logic that surrounds each one of these proofs by using as few steps as possible, but actually making you still put enough information there that you're justifying.